Hello mga ka-tribes! Welcome to Daddy Brew TV. For today's video, let's have Lesson 2, Mass Function of a Discrete Random Variable. In this lesson, you will learn to construct the probability of mass function of a discrete random variable and its corresponding histogram. Now, the probability distribution of a discrete random variable is called probability mass function or PMF. The values of the discrete random variable x, where f of x greater than 0, are called mass points. Now, let's discuss properties of a PMF. The PMF of x is denoted by function of x and satisfies the following two basic properties. Property A: for every element x in the supports S, all the probabilities must be positive, denoted by function of x is equal now to the probability of x equal to x is greater than or equal to 0 if x element the support S. Property B: the sum of all the probabilities of all possible x values in the support S must be equal to 1, denoted by sigma of fx as x element of S is equal to sigma of the probability of x equal to x as x element of S is equal to 1. Let's have example number 1. Suppose a random variable x can only take the 4 values 0, 1, 2, and 3 if each value has equal probability. What is its PMF and its support? For our solution, since each has equal probability, then the PMF or the function of x is equal now to the probability 1/4 if x is equal to 0, equal also to 1/4 if x is equal to 1, equal also to 1/4 if x is equal to 2, and equal also to 1/4 if x is equal to 3, and equal to 0 otherwise. Simplifying further, we have now the function of x equal to the probability 1/4 if x is equal to 0, 1, 2, or 3, and equal to 0 otherwise. Hence, the support S is equal now to 0, 1, 2, 3. Now, let's have example number 2. Let f of x equal to kx, for x is equal to 1, 2, 3, 4. Find the value of k so that function of x satisfies the two properties of being a probability mass function and represent in a table and graphical form. To find the value of k, our solution is we are going to use property B, that is the summation of the function of x as x element of S equal to the summation of kx as x is equal to 1 up to 4 equal to 1. Substitute, since we are looking for k, substitute, that is now 1 equal to k times 1 plus k times 2 plus k times 3 plus k times 4 up to 4 only. And simplifying it, we have now 1 is equal to 1k plus 2k plus 3k plus 4k, which is now equal to 1 is equal to 10k. So Dividing both sides by 10, we have now k is equal to 1 over 10. Now, k is already obtained. So our equation now is for x element of 1, 2, 3, 4, the probability of x equal to x is equal now to 1 over 10x greater than 0. Since k is equal to 1 over 10. And for x not element of 1, 2, 3, 4, the probability of x equal to x is equal to 0. Simplifying, we have the PMF or function of x is equal now to 1 over 10x if x is equal to 1, 2, 3, and 4 and equal to 0 otherwise. Now, substitution or by substitution, we have now the probability of x equal to 1 is equal to 1 over 10. In the function f of x is equal now to 1 over 10x. So if x here is 1, then what that is 1 over 10. If x here is 2, that is now 2 over 10. And the probability of x is equal to 3, that is 3 over 10. And the probability of x is equal to 4, that is 4 over 10. So therefore, the probability of x equal to x is greater than or equal to 0. Take note, 1 over 10, 2 over 10, 3 over 10, and 4 over 10 are greater than or equal to 0. Now, for property B, to check if the sum of the probabilities is equal to 1, we have summation of the probability of x is equal to x, which is now equal to 1 over 10 plus 2 over 10 plus 3 over 10 plus 4 over 10. That is now equal to 10 over 10 or 1. So, both properties are met. So, k is equal to 1 over 10. And the above probabilities can be presented in tabular form. So that is now x is equal to the assumed values or values 1, 2, 3, 4. And the probability of x equal to x is 1 over 10, 2 over 10, 3 over 10, and 4 over 10. And so the probability mass function or PMF may also presented in graphical form. Along the x-axis, we have the values of x 1, 2, 3, 4. Along the y-axis, we have the values of the probability of x equal to x. So if x is equal to 1, the probability is 1 over 10. So just draw a bar graph. If x is equal to 2, the probability is 1 over 5. If x is equal to 3, the probability is 3 over 10. If x is 4, the probability is 2/5. And that's the graphical form of the PMF. Now your turn. Consider the PMF function of x is equal to 1 over 6x if x element of 1, 2, 3 equal to 0 if otherwise. Question: show that the probability of x equal to x is indeed a probability mass function. Solution. Now, for property A or property 1, the probability of x equal to x is equal to 1 over 6x greater than 0 for x element of 1, 2, 3. And the probability of x equal to x is equal to 0 for x not element of 1, 2, 3. Therefore, the probability of x is greater than or equal to 0. The non-negative property of the probability mass function is satisfied. Now, let's check property 2. By property 2, the summation of the probability of x equal to x as x is equal to 1 up to 3 is equal to the probability of x equal to 1 plus the probability of x equal to 2 plus the probability of x equal to 3. That is now equal to 1/6 times 1 plus 1/6 times 2 plus 1/6 times 3. Simplifying it, we have 1/6 plus 2 over 6 plus 3 over 6, which is now equal to 6 over 6 or 1. The property that the sum of the probabilities is equal to 1 is satisfied. Therefore, the probability of x equal to x is indeed a probability mass function. Thanks for watching. See you on my next video. Bye.